Today's session we will discuss about structured design concept in software architecture. Okay, so first we'll discuss about what is this design and how this design is going to be refined in each and every stage, and what are the different architectural styles we are using, and what are the consequences that we have between this architectural styles. Each and every design will be dependent on one architecture in the context that they are developing based on the application or based on the system. So we will see what are the consequences between call and return and pipe and fill filter architectural state, and what are the weaknesses and how it can be improved in one and its advantage. So to start with, architecture design is something where you will design the system or design the applications. The process of the application will be designed in the format of the architecture. So for this designing, there are more number of architectural styles like call and return, pipe and filter, data center. Like this, there are several styles in which the design has been will be structured. So we will see one by one what is this design will have and all. So okay, usually design the working system only will be converted into a design. So to analyze or to find out what is the purpose of the system. So we will be having if you take one system or one application, you will be having number of modules like components. So every project will be having different components, different modules. Every modules will be every module will have its own properties. Will have like for to be very specific in example, if you take Amazon, the customer is one component, the website is another component, the one who deliver is the other component, the one who takes up the request is one component. So each and every component, or you can call it as a module, will be communicating with each other. So how this communication will happen? Communication will happen with the connectors. So the interaction between them. So interaction between the between the modules and how they transfer the data. Everything will be everything will be in the architecture, the designed architectures that we are going to have. So the structure chart will be consisting of modules and connections. So module is a component, and how the component is going to interact with each other will be defined by the connection. So the module, the connections, you have one more thing, that is allocation. Everything will be dependent upon the style that we choose. If you take call and return, the filters and the connections will be in a different format. If you take module, that will be in a different format. So one by one we will be discussing it when you see the consequences. So we have designed the architecture now based on the system that we take with the help of this module and connection. Next, we will be refining it. So refining is first you just give generalized representation of the system, working model of the system, and you will refine it. So refining means giving more generic view of the particular component. So if we have the small component, it will give you the generic view or the detailed view of the particular component. So the stepwise refinement is a discipline of taking small and easily defended steps from the very generic view of the algorithm and adding a few details to each step. So first, initially, we will be discussing about like your data flow diagram level 0. We will be having, okay, this is a component. These are the modules that we have. This is how the whole system will be represented with one circle or one bubble. So after that, we will go with the level 1. How the level 1 is being made, it is a refinement. So each and every module will be found out in the level 1, and how what that module will be doing will be representing in the DFT model, level 0, level 1, level 2. So at the end, you will be having one diagram where you cannot even give the detail of the particular process that you represent there. So like those process or those bubble, you call it as primitive process, where the primitive process cannot be extended after that. So that is what stepwise refinement. First, we will be giving some general representation. So everything will be described in a very subtle way. And after that, every refinement means each and every step, if you refine, you will be adding more details to the component that you specify. So there are some consequences in the architecture that we are using to design. So we will focus on what are those consequences. So we will take two styles. One is call and return, another one is the pipe and filter. So call and return less. Yeah, so this is the diagram representation of call and return, and this is the diagram representation of pipe and filter. If there is a call and return, the compiler is a component, and lexical analysis component. Everything is a component, or you can call it as a module. How they are going to interact with these are the interaction medium that we have, or the link we can say. So the compiler will be sending the data to the lexical analysis. Lexical analysis will process, this component will process, and this again will give back to the higher component. So the higher component is a compiler. All the lexical, syntax, semantic code are the lower level components. So this higher level component work is to aggregate all the work of this lower level. So every data that is being sent also, it is not viable. It can be changed by the third party. So it is not consistent. Data is not consistent when you take call and return style. So the compiler component will give to the lexical. Again, lexical will send. Same like that, syntax, semantic, and code generation. So this is where your data is not consistent, and so why there is some consequences in call and return. And if you take pipe and filter, so data are not sent out, out of the component. It is being given to the next one. So there is not the possibility of stealing the data is less, and data are consistent. So it is depending upon the application. If the application suits with the call and return style, you can go with call and return style. If the application suits with pipe and filter, you can go with the pipe and filter. So see, the higher level units of call and return solution have roles to coordinate and sequence the lower level units. It may be worth considering the pipeline. Why? Because the pipeline will have data consistency. That is the one benefits that we have. So the strength to be one of the benefit of the pipeline solution is to better able to incorporate the ideas. Yes, as I told you, it is not data, since the data is consistent, information is hidden. So the information is hidden, and the problem of the call and return is that the data is not easily confined within the particular element. Since it is going back and forth, it is not confined to only one element. So in some cases, we cannot make this call and return architecture to be implemented if it is a more secured application or system. On that case, you can go for pipe and filter. This is all representation. None of it we are implementing. It is all we are representing the process, the working process in terms of architecture. So architecture, it is not just diagrams. It is going to tell you the entire process. If the architecture is right, the implementation also will be right. So why it is being given much importance to represent the every working process of the system in terms of architecture. So the strengths of this stepwise refinement in each and every style is every process or every leaves, everything that every step that we take will be represented here, and the data is confined, and we can also go back. You can backtrack. If there is any error, you can just go back and find out what is the error. And this backtracking is a feature, one of the feature in all the ADS, architectural description language. So this is every step that we take in the design process is noted in the architectural style. The weakness, as I told you earlier, the stages, each and every style will have its own weaknesses. But when it comes to pipe and filter and call and return, data is not confined, information is not hidden, and to manage this, to call and return, it is much work is needed, and to manage this pipe and filter, we have less maintenance. And a lack of stopping rule, which although inconvenient, does not render the process invalid in any way, and the problem of duplication of lower level units. And you like this process, the data is not confined to the component. This data is not confined to it is sent to the outer world. So in that case, we cannot say that the data are secured, or it will not get duplicated and all. So it is better to go for pipe and filter architecture to the applications where you have more security, where you need more security, And where there is less security and just a representation, just you can go for calling. Yes. Thank you.